Practical problem solving for oblique triangles. We have an example of a problem for you to use your problem solving skills on a real-world problem. Kimberly and Peter are in towers that are 3 miles apart. Kimberly spots a ship from her tower and notes that the angle between her line of sight to the ship and the port tower is 53 degrees. At the same time, Peter, who is in the port tower, notes that the angle between the line of sight to the ship and Kimberly's tower is 42 degrees. What is the distance between the ship and the port tower? We have an illustration of this problem on the board. KT stands for Kimberly's tower, and PT stands for Peter's tower, and we note that Kimberly's tower and Peter's tower are 3 miles apart. Kimberly sights a ship in the harbor, and she notes that the angle that her line of sight makes with her line of sight to Peter's tower is 53 degrees. At the same time, Peter notes that his line of sight to the ship makes a 42-degree angle with his line of sight to Kimberly's tower. And we want to find the distance from the ship to Peter's tower. If we look at this problem, it looks like a great example of an oblique triangle problem, and we'll use our oblique triangle problem-solving skills to work it out. We like to use the law of sines if we can, but I don't have any relationship right now between a side and an angle. I'm in luck, however, because I know there are 180 degrees in a triangle. So if I wanted to find this angle, I know that that angle, which we'll call x, plus 53 degrees plus 42 degrees is equal to 180 degrees. That would mean x plus 95 is equal to 180 degrees, and that little angle would have to be 85 degrees. So we can mark in here that this angle is 85 degrees. Once you have that angle, it's okay to use the law of sines because I have an angle and the side opposite the angle. In the law of sines, we know that we're going to set up the side over the sine of the angle opposite that side. So I'll have 3 over the sine of 85 degrees. That's going to be my basic ratio for this problem. This is the side that I want to find. I want to find this distance. So I'll set up another ratio and say that's equal to x over the sine of 53 degrees. When I'm solving this proportion, I know that I just have to cross multiply. I'm going to get rid of this number that x is divided by, and I'm going to multiply sine of 53 on both sides of the equation. So I'll multiply sine of 53 degrees here and the sine of 53 degrees on the left as well. These will cancel, and it tells me that sine 53 times 3 over the sine of 85 will give me the length of the distance between the ship and Peter's tower. Coming to the calculator, I'll find the sine of 53 times 3 divided by the sine of 85, and I find that the distance is 2.41 miles. The distance from the ship to Peter's tower is about 2.41 miles. Using a simple application of the law of sines has helped us to solve this problem.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.